Welcome. In the previous videos, we have made discussions on discrete random variables. Okay. In the discrete random variables, how do we define the joint mass function with which how do we find the marginal PMF and conditional probability? All these things we have seen. Here we have two continuous random variables. This function is known as joint density function if these conditions are satisfied. That is, probability that x is lying between a and b and y is lying between c and d, and this is simply integral a to b integral c to d f of xy. If the inner integral is with respect to y, then this limit should be here. Okay, and this can also be written as integral c to d integral a to b f of xy, and the inner one is with respect to x and the outer one is with respect to y. Okay, and again remember, this is a density function, therefore at every point it should be greater than or equal to 0. Okay, and integral, the entire integral is 1 since it is the probability density function. And here distribution function, we just define it from minus infinity to that particular point. Okay, and just like we had marginal PMF, here we have marginal density functions. Okay, given we have the given the joint density function of two variables, how are we going to find out the density function of a particular variable which is involved? So fx of x is just the integral of this density function with respect to y. We are taking all possibilities for that y, and we are just having the value for only x. Similarly, one can define for the marginal PDF of y. Okay, and two random variables are called independent if f of xy is same as that of fx of x and fy of y. Okay, so this one we can have it as a definition for independence of two random variables. Okay, we come to the problem and try to solve it. Here we have the joint PDF of two variables. Okay, and we are asked to find out the value of k at the first instance. That is integral from 0 to 2 and integral from 0 to 4 k times of 6 minus x minus y. So the inner one is with respect to dy and the outer one is with respect to x, and we know this is equal to 1. So we just take this k outside, integral 0 to 2 and this is with respect to y we are integrating. So 6y minus xy minus y square upon 2, 0 to 4 dx equals 1. So this is k times of integral 0 to 2. This is 6 times of 4, that is 24, minus 4x minus 16 upon 2, and everything else is 0. Right? So this is what we have, dx equals 1. So what we have is k times of integral 0 to 2, this 24 minus 8, isn't it? So that is 16 minus 4x dx is 1. Therefore, k times of 16x minus 4x square upon 2. So that is simply 2x square over the limit 0 to 2, which equals 1. Therefore, k times of 32 minus 8 and everything else is 0 equals 1. So k times of 24, that is 24k is 1. Therefore, k is 1 upon 24. Right? So now that it is upon 24, this is your joint PDF. So first thing is done. Now we are asked to find out the marginal density functions. That is your fx of x. That is, you will have to integrate this 1 upon 24 times of 6 minus x minus y with respect to dy. So this y is taking the limit 0 to 4. So it should be 0 to 4. Okay, so this 1 upon 24 is a constant, so we take it outside. This is 6y minus xy minus y square upon 2, 0 to 4. So 1 upon 24 times of, if you just substitute this limit, what you are going to get is 16 minus 4x. So this is your marginal density of x. Similarly, marginal density of y is integral 0 to 2 1 upon 24 times of 6 minus x minus y dy. So this is a constant. This is 6x minus x square upon 2 minus xy over the limit 0 to 2. So 1 upon 24 times of 12 minus, sorry, we are integrating it with respect to x, isn't it? Yeah. So 12 minus, if we substitute this one, we would get a simply 2 minus 2y, isn't it? So it is 1 upon 24 times of 10 minus 2y. This is the density function of, marginal density function of y. Now we need to find out the probability of x plus y less than 4. This shall also be written as probability of x less than 4 minus y. Okay. Now we have the restriction on x and we don't have any restriction on y. So integral of the given function 6 minus x minus y times of here we have the restriction on x from what? From 0 to 4 minus y. Whereas we don't have any restriction on this one. Okay. So inside is for x and outside is for y. Now that we need to perform this integration. Suppose if you don't know how to find the limits of this one, you know this is x plus y equals 4, isn't it? So this is the region for which you will need to find out the probability, and this is y equals 0, right? And this is x equals 0. Okay, and this point is x equals 2 and this point is y equals 4. Okay, now you fix one thing. So if you are, now we are changing y, okay, sorry, x is from 0 to y minus, sorry, 4 minus y. Okay, just like in your usual calculus how you perform these calculations, the same thing can be applied here as well. So when we perform it, it is interval 0 to 4, 1 upon 24 can be taken outside. So it is 6x minus x square upon 2 minus xy over the limit 0 to 4 minus y. Okay, and this has to be integrated with respect to dy at the last. So 1 upon 24 interval 0 to 24. It is 6 times of 4 minus y minus 4 minus y whole square upon 2 minus y into 4 minus y. And finally we have dy. Okay, when you substitute 0, everything else is 0. Now that you need to make some simplification, okay, after performing the simplification, you just need to integrate it again and substitute the limits. That's it. Okay, I leave it to you guys. Next, we have the joint PDF of two random variables here. Okay, PDF is given. We are asked to check the marginal density. Okay, let us evaluate it. So fx of x, that is what? Okay, so we should have xy e to the power minus x plus y. Okay, x. So we'll have to differentiate this one from 0 to infinity, right? So we are just going to integrate with respect to y, which means x is treated as constant. So this x shall be taken outside. this can also be taken outside. So 0 to infinity y e to the power minus y dy. Okay, we just need to apply integration by parts. So u is y and dv is minus e to the power y. Okay, and when you minus times of integral e to the power minus y dy, this is simply plus e to the power minus y over this limit, isn't it? So x e power minus x, and if you substitute this here, e to the power minus infinity is 0, here also it is the same, and this 0 makes this to be 0 and this is 1, isn't it? So what we have is 1. Just a minute, is it 1 or minus 1? Yeah, it is minus 1. No, uv minus integral b du, but v itself is minus, so it is minus. Yeah, so we have x e to the power minus x. In a similar way, if you find out this one, this is y e to the power minus y for x positive here, and here it is y positive. We have found the marginal density. Okay, and what is fx of x? Product fx fy of y, it is x e to the power minus x multiplied with y e to the power minus y. This can also be written as xy e to the power minus times of x plus y for x positive and y positive. This is or what? F of xy. So here x and y are independent. Now we are asked to find out x smaller than y. Okay, so this one is integral xy e to the power minus x e to the power minus y. Okay, x is varying from 0 to y, whereas y does not have any limits. Okay, so x and y. Okay, now here you can take this y thing outside. Since we are going to integrate with respect to x, we just take this quantity outside. Okay, and now integral 0 to y, so this is going to be x, right? So minus x e to the power minus x minus e to the power minus x, and this is from 0 to y, and finally we are going to integrate it with respect to y. Okay, so integral 0 to infinity y e to the power minus y, and when we substitute it, minus y e to the power minus y and minus e to the power minus y, and when we substitute it, it is 0, and this would be plus 1 and dy. Okay, so integral 0 to infinity minus, it is minus y square e to the power minus 2y and minus y e to the power minus 2y and plus y e to the power minus y and dy. Okay, all we need to do is to repeatedly apply integration by parts for this term, and once integration by parts to all the three terms, and we'll have to find out the value. Okay, so I leave it to you, the remaining calculations. That's it. Thank you.